Good morning, good afternoon, good evening, and welcome to our webinar today, Lifecycle Assessment of Cobalt Products. My name's Tom Fairley and I'm Senior Sustainability Manager at the Cobalt Institute. Before I start, I'll introduce the Cobalt Institute for those who are not familiar. We are a global not-for-profit industry association representing the full cobalt value chain, so upstream miners, midstream refiners, downstream users, recyclers and so on. We're a member-led association and we represent at least 80% of globally produced cobalt. Our remit is to ensure the sustainable and responsible production and use of cobalt in all its forms. Now, the CI is well known for its global knowledge hub in chemicals management, but we're also involved in government affairs and, of course, responsible sourcing and sustainability, of which I'm a part, which is led up by Susanna McLaren. So today, our webinar is going to focus on our recent Cobalt LCA results. We're going to be making a short presentation of these results, but I'm delighted also to be joined by four panelists who I'll be introducing shortly, and they'll be talking about the Cobalt LCA, how they use LCA, and some of the challenges and opportunities around LCA production. This session is being recorded today, so you can follow up afterwards, and any presented materials will also be available afterwards. There is a Q&A function on your Zoom browser, so please, if you do have any questions about the LCA or to our panelists as we go through our panel session, please do ask those questions. So without further ado, I think I'll get down to brass tacks and start going through our Cobalt LCA results. So I think, first of all, it's very useful to give a bit of background on the Cobalt LCA and LCA more generally. So, why are we producing these data? I think it's important that we have highly reliable and good quality data so that impacts can be properly understood, and any measures we take to address these impacts and any improvements can be measured. So the Cobalt Institute's own lifecycle assessment journey started with the issue in 2015 of its first LCA report done by ERM, and this was just looking at cobalt metal. It had a reference year of 2012, and for global warming potential, so the carbon footprint of cobalt metal, this was found to be 38 kilograms CO2 equivalent per kilogram of cobalt metal. Well, obviously, a lot of time's elapsed since that reference year, and there's also an increasing interest in cobalt materials, particularly around the EV battery sector. So there's been a high interest from OEMs, battery manufacturers, civil society, policymakers, and so on. So it's important that we update the LCA and address those stakeholders' needs. So we're also updating this forthcoming legislation. You have the batteries product environmental footprint category rules that needs data, and also you have initiatives such as the Global Battery Alliance Rulebook, the Battery Passport, the GBA of which the Cobalt Institute is a member. And I think finally also, based on these data, there was an assumption that cobalt might be a hotspot in EV batteries, so this old data perhaps doesn't actually reflect the real situation. So on to our current LCA. Some key elements here. So the reference year now is 2019, and we started production of this in early 2020. The functional unit is per kilogram of product. So it's the impact per kilogram of the four products now that we have here. So firstly, we have cobalt metal again. Then we have crude cobalt hydroxide. So this is an unrefined cobalt compound, predominantly from the copper cobalt root. Then we have our two battery precursors. We have tricobalt tetroxide, which is predominantly precursor for lithium cobalt oxide batteries, so in your portable consumer electronics. And then cobalt sulfate heptahydrate, and this is a precursor for predominantly NMC, nickel manganese cobalt EV batteries. So we followed the methodology set out in a harmonization document that was created in 2014 by the Metals Association. So there's a common approach that's being taken by all metals associations. This was then published as an academic paper, Santara and Henry in 2016. So it can be referenced if you wish to investigate that further. And we have chosen 4 impact categories and 2 environmental indicators to report. So the first I've talked about already is global warming potential. Then we have eutrophication potential, so the introduction of nitrogen and phosphorus to the environment. Acidification potential, introducing hydrogen ions to the environment. Ozone creation, so as a result, for instance, from emissions of VOCs. And then we also have primary energy demand, the amount of energy required to produce the product, and blue water consumption, the amount of water taken from the environment and not returned to where it was taken. So on to a little bit more about the system boundaries. We are looking at a cradle-to-gate boundary. So this is from mining the resource through to the refining of the cobalt product. And you can see here we have inputs, ore, energy, waters, and outputs, emissions to soil, air, water. And then we have our 4 products coming out as well. We account for the production of electricity, fuels, auxiliaries such as chemicals. And we also account for byproducts, and this is probably a good point to discuss cobalt as a byproduct. 98% of cobalt comes from either a copper or a nickel route as a byproduct. And so it's important to allocate impacts accordingly. Following the harmonization document that I referred to earlier, we're taking the approach of using mass allocation generally. So if there's 5 times the amount of, say, a copper ore compared to a cobalt ore, we allocate any impacts proportionately there. One exception, for instance, is where we use economic allocation, where platinum group metals are extracted, are removed from a stream. And here we're using a 10-year average for this economic allocation rather than mass allocation. And I think finally, and we'll get on to this slightly later, we've broken down the process into 4 stages. So we have mining, the initial sort of blasting or extraction of the ore. Then we have beneficiation, the ore preparation, separating and crushing. Then primary extraction, so this might be the pyrometallurgy, hydrometallurgy processes, so the inputs of heat and chemicals to further purify ores. And then finally, going into the refining stage where we work to get our final cobalt products. So I want to take a moment to talk about the representativeness of the results, because I think this is something we're quite proud of. For cobalt metal, the results we produced represent 55% of globally produced cobalt metals. This is very high representativeness, giving us really quite robust figures. Equally, with crude cobalt hydroxide, we have about 37% of globally produced crude cobalt hydroxide. Again, highly representative. Then we've obviously increased the representativeness of the study by including these additional cobalt products, including the oxide and the sulfates. For the latter 2, we have about 9% of global production. So this is less representative and does reflect the fact that the study did not include Chinese refiners in the study. We had in total 12 companies and 29 sites, but no Chinese refiners. So we have undertaken some work to better understand the footprint of Chinese refining, but there are some challenges with data gathering and gaps in these data, such as process emissions, which really make the data sort of less robust, and it's not really possible to make a good comparison with the sort of robust data set that we have here. But it is something that we are working on. So I think finally, after all that preamble, we have final results. And I will just focus on global warming potential today for purposes of brevity. But we have our 4 cobalt products here, and remembering that this is impact per kilogram of product. The amount of cobalt contained here is also listed, the assumptions on what percentage that is. So first of all, we have 1 kilogram of cobalt metal, and that has a global warming potential of 28.2 kilograms CO2 equivalent. Then we have 1 kilogram of crude cobalt hydroxide, and this is 6.4 kilograms CO2 equivalent. Then we have 1 kilogram of tri-cobalt tetroxide, and that is 24 kilograms CO2 equivalent. And then 1 kilogram of cobalt sulfate heptahydrate, and that is 4 kilograms CO2 equivalent. So we have these figures also for the other impact categories, which I won't go into now. And also, I'll take this opportunity to note that these data are on the Cobalt Institute website, so if you want to look in them in a little bit more detail, please do go there. Also, for LCA practitioners, we do have data sets for these global average aggregated data. We will shortly be publishing these in ILCD format on the Cobalt Institute's data node. Gabi will be updating their database in early 2023 to include these data. And we're also working with EcoInvent so that these data can be in the EcoInvent database probably around September 2023. So, this is a sort of high-level overview, but we actually went into a little bit more detail and a bit more disaggregation, so we can start to really understand where the sort of hotspots are and where we might need to focus. So today I'm just going to focus on cobalt metal for purposes of brevity, but I think this gives a really good example of where there's a lot of power in this data and where we can use this to really target efforts, in this case looking at global warming potential, around decarbonisation. These slides are available afterwards, and the data is on the Cobalt Institute website. So first of all, we have the pie chart in the top left-hand corner, and we see here that primary extraction actually forms a little bit over half, that blue section, a little bit over half of the impact. The next biggest stage as far as impact is refining, and that's a bit over a quarter. Perhaps not surprising for those who are familiar with LCA is that transportation, so something that's really visible in global value chains, actually only makes up around 3% of the impact. So although something that needs to be addressed, it's certainly not the main priority as far as hotspots where we as industry have the opportunity to make impact. Then the next pie chart we have is looking at scope 1, 2, and 3 emissions. So we see here scope 1 emissions, so this might be on-site energy, electricity production, or the use of, say, diesel on-site. This is about 60% of the impact. So here, there's opportunities for using low-carbon energy, electrification of vehicles and processes that may reduce this. And then the next biggest section is scope 2 at about a third of the impact. So here, obviously, a real opportunity for decarbonisation by using a renewable energy source and addressing that scope 2. But then we go into a little bit more detail on the right-hand side and the bar graph here, where we have these different stages, but we also break down into where the impacts actually lie. And like I say, this is where these data have some real value, because we can focus on where the impacts might be. So primary extraction, I highlighted earlier, is where there was the biggest impact. And we see here that on-site electricity is the biggest impact. So obviously, using low-carbon energy, renewable energy would be a way of addressing this. Then direct emissions, again, reducing the use of fuels and using low-carbon renewable energy could address this. But then we go on to refining, which is the second biggest impact. And we see here that blue bar in the refining part is auxiliaries. So this is chemicals predominantly. And so there's an opportunity here to reduce scope 3 emissions, work with chemical producers to you have lower carbon intensity chemicals going into processes. So this data is really informing where we go forwards as Cobalt Institute and as an industry around initiatives on decarbonising our value chains. So I'm going to finish off here, and just to sort of summarise, we have these data available on the Cobalt Institute website. If you would like a copy of the full peer-reviewed LCA report, contact us and we'll be able to share that with you as well. And of course, we will have the LCA data available on various databases shortly. So that brings me to the end of presenting our results today. And so I now want to turn to our panel and introduce our panel. It's my pleasure to introduce this panel today, who'll be talking about Cobalt LCA, how they use LCA, the challenges around LCA and LCA production, and any opportunities we have as sort of industry going forward with LCA. So without any further ado, I'll start introducing our panel. Firstly, today we have Robin Stoney, Manager of Regulatory Affairs, Nickel and Cobalt at Glencore. Glencore, the multi-metal producer and sustaining member of Cobalt Institute and participant in our Cobalt LCA. So welcome, Robin. Then
Hello, Tom. Congratulations on the publication and thanks for the opportunity to join you today.
Pleasure, thank you. Then we have Ketan Vaidya of Northvolt. He is the life cycle assessment analyst. Northvolt being the Swedish-based battery manufacturer of low-carbon AV batteries. Good morning, Ketan.
Hello, Tom. Thank you. Thanks for having me here.
Next, we have Dr. Claude Chancel, General Manager of Recharge. Recharge, the European Battery Association, leading work on the batteries PEF, Delegated Act of the EU batteries legislation. I think you're on mute there at the moment.
Yes, I just said thank you for inviting me. Good morning, good afternoon, everybody.
Good morning. And finally, we have Dr. Mark Mystery, Senior Manager of LCA and Sustainability at the Nickel Institute. The Nickel Institute, fellow Metals Industry Association colleague.
Good morning, Tom.
Good morning. So, as I suggested, I've set out some areas of discussion, so I think I'll just get straight down to questions and start with Robin. I guess, what are your key takeaways from the results? And as a participant of the LCA, how are you using the results and LCA more widely?
Yeah, thank you, Tom. The industry averages make qualitative real information available where alternatives might be based on desktop research and not specific data. So I think they add excellent real information to the area that we are trying to manage. Cobalt is a critical raw material with many benefits and growing demand, and also costs that are social and environmental. So the key indices presented in the LCA provide a detailed understanding of the environmental impacts and baseline that the industry can use then to manage and balance increasing the rate of production of cobalt against the potential increase in detrimental environmental impacts. So that's, high level, but then, from a detailed perspective, we've got a range of stakeholders that can benefit from this additional verified data, where there might be an absence of similar operation-specific values, for example, for the preparation of environmental footprinting information for both downstream users and LCA practitioners. So I think it's a great step, and it's going to be adding a lot of value to a range of areas. And I think for Glencore, it provides a useful benchmark that assists us to guide our assessments of our own environmental performance and continual improvement projects.
Excellent. Thanks, Robin. Yeah, I think hearing that need for a benchmark perhaps is quite a vital part that all those secondary data can really add to the industry. Wonderful. So, Ketan, I think a question to you then, as a downstream user and an LCA practitioner, how will you be using these data? And I guess, how do you use LCA more widely in Northvolt and in your work? And how important is that?
Thanks, Tom. Thanks for the question. Really interesting one. So, congrats on the results, first of all. And based on this, what we can do is to drive more quantitative-driven decision-making. So basically, a lot of times we can use the data more intelligently to figure out what are the drawbacks, what are the bottlenecks, and how we can minimize those. So it can come down to choosing the suppliers which are more sustainable than the other, and as well as choosing the right feeds, which are more sustainable.
Excellent. And I guess with the LCA work you're doing, does this really drive how you approach suppliers, and how are you? How does this benchmark sort of help you?
Yes. So regarding this results, what we can see from the results is that we identify some of the steps as key bottlenecks, and then we can derive a generalized decarbonization measures, and then figure out which are the players and how this can be used more widely to minimize and to have this transition from electrification more sustainably.
Brilliant. No, good to hear that that's a big driver for what Northvolt are doing. Claude, I think a question to you, and perhaps you can give a bit of colour on this, and a bit of background to, firstly, the batteries, PEF, Recharge's involvement in that, I guess the importance of PEF and what it means. But then also moving on to how these data can support this and the work of policymakers as well, more generally.
Thank you for the good question. Yes, indeed, as you mentioned, PEF is today really has become a political tool. So it's showing how large the ambition from the European Commission in these decarbonization trends is about using these LCA type of data information based on the PEF, which is in fact one example of a kind of specialized standard for LCA usage in order to calculate environmental impact. Particularly, as you know, we have at the moment this new batteries regulation, which has been, by the way, agreed last Friday in trilogue. So things are moving close to an end now. And we see indeed a direct usage of this very important input of Cobalt data sets, for example, as one of the key data sets which are relevant to calculate the correct carbon footprint for the batteries carbon footprint declaration. So that's showing how we are now really close to use directly these type of tools and data for direct consumer information about and helping the consumer make so-called informed choice about the carbon impact of their purchasing decision. That's how we see now the usage of the PEF for the carbon footprint. In addition, as you know, there are also this usage of PEF, more generally, the PEF method, product environmental footprint for the green product declaration, which would be a more global view of what are the environmental impact when you intend to make a declaration of your product impacts in general. This is a regulation to come in 2023, which will once again based on the PEF method to make these green claims. So in this field, we very much appreciate your effort, because these so-called secondary data sets, which represent in fact the typical or average industry, you clearly mentioned the representativeness of your data set is really important and welcome to make sure that we have relevant information and accurate information to clarify on the total impact of products. Of course, we are, as Recharge, focusing on batteries, but we know that this method may be used in a much broader field and not only for batteries. And therefore, this availability of updated data set with a clear identification where are the hotspots and how these will contribute to the final global product are absolutely essential to generate this expected credibility and transparency of communication that the Commission is so much promoting for these green claims or carbon footprint declarations. Well, that's, let's say, a general overview to introduce the topic.
No, brilliant. Thank you very much for that. I think you really sort of set the scene on the work that's happening now and ongoing. I picked up some key points. Credibility of data, I think that's really important, absolutely. Then having the information available to consumers also and in that decision-making process also. And you rightly point out we have a big focus on EV batteries, but there are, of course, broader uses of Cobalt as well. And these data, not just on the batteries PEF, but wider use of PEF ongoing. So I think thank you for highlighting that as well. And Mark, over to you. So I guess from an industry association perspective, how important is it to produce these average sort of data sets, and I guess also in a consistent manner as well?
Yeah, thank you, Tom. I mean, first of all, as I'm doing currently the same exercise for the fourth time at the Nickel Institute, I would like to congratulate you, as I know how tough it is to actually get players from industry collecting these data and going through the entire process of updating the information. I think there are two perspectives why the collection of these data is so important. The first one, as Claude rightly pointed out, is the use of these data in so-called hotspot analysis. So when you assess systems and when you want to know which part of the life cycle is actually a so-called environmental hotspot where you need to dive a bit deeper and where you need company data, these data are quite important. And therefore, having the Cobalt Institute collecting these data is actually, I think, for someone like Claude, but also when we look into other important value chains of critical importance. The other point is looking at Ketan. I think that for companies using, for example, Cobalt in your case, it is of course also important to know that you are providing your member companies with a company and site-specific report that they can use to satisfy data requirements from companies like Northwood. So it's both that you, on the one side, ensure that there are industry average data made available to conduct a hotspot analysis, and on the other side, to fulfill data requirements from customers. The other point I would like to stress is, in these days, it is quite important to also highlight that the industry is committed. This is a huge effort that the Cobalt industry has committed to. And in terms of budget, in terms of internal resources, and I think it's sending a very clear signal into the value chains to regulators, to other stakeholders around us that we are actually looking into carbon footprint. We are looking into greenhouse gas emissions and beyond that, and that we actually want to provide those stakeholders with the most recent data. And the last point I would like to mention is of course, that it is also critical to understand that these are high quality data. They are going through a peer review process. The data most likely will be audited, as they are going to be used in a regulatory context. So from that perspective, as said, once again, Tom, congratulations. Congratulations also to the member companies who committed to do this effort jointly with you.
No, thank you very much, Mark. I'm glad you raised that point around the effort. It did feel like it was that last stretch getting it over the line, but I think we're very pleased with the fact we've achieved that and quite happy, as you say, robustness of data. And I think the idea of having that sort of benchmark as well for industry has been raised by a number of you with these first questions, and I think that sets an important line for people to refer to going forward. So I think some interesting reflections there, and thank you for those. Looking on some of the challenges, because as Mark, you alluded to, it can be a bit of a struggle pulling together these data, and there are wider problems and challenges that we need to address as individuals and as an industry and value chain as a whole. So I think over again to Robin, and I guess what challenges are there in your data gathering, and also I referred earlier to Cobalt being predominantly a co or byproduct, in your case, cobalt nickel. How does this complicate things, communicating things when we're talking about allocation and so on?
Yeah, so I guess it's the variability in product and byproduct relationships. So different products having different LCAs, and then the comparability between how those products look in those when you try to put the things together. Essentially, there are some different subdivision methods, and where mass and value are used, and particularly where values are applied, there can be differences, and this can result in some variability that I think needs to be understood by the stakeholder group, and we need to find ways to communicate that potential variability in a way that makes sense for the broader audience of this data. So I think developing the knowledge amongst the stakeholder group that can then help inform choices. Consistent high quality data is obviously key to resolving that, and I think the industry also needs to work towards building that stakeholder knowledge and data set, which is exactly the process that we're involved in. So it can be met, but it's definitely is a bit confounding in terms of being able to reflect this data into the stakeholder group in a consistent way.
Brilliant. And I guess just to sort of build on that, are you seeing with your stakeholders an increased interest and increased requirement for data, and sort of what are the challenges in managing this change? And I think it's been quite recent, a significant change in the requirement for data, and as you say, understanding of the quality of the data and the limitations of the data as well.
Yeah, and you don't want to drown stakeholders in complex information that's not helpful to them, but at the same time, you need to be able to be transparent and start to provide information in a space where there maybe isn't a lot of information available. So I think the LCAs are an important part of that, in being able to sort of have that benchmark, put it forward and say, okay, well, there are limitations. We need to understand those together and be able to work together on resolving some things over time. And then, if people are using the information in a useful way, in a way that's useful to their purposes, I think that's really important. So yeah, definitely lots of interest and lots of people looking for more information in the life cycle assessment space.
Brilliant. Thank you, Robin. Mark, I think challenges, like I say, we face a few whilst we're actually developing the data and gathering that. What sort of challenges do you see producing these data? And I think also, consistency of approach we perhaps touched on earlier, but perhaps you could talk a bit about the challenges we face going forward around maintaining and achieving consistency, and what we can do as industry.
Yeah, I think there's a wide range of different challenges that we are facing when collecting these data. On the one side, the more we learn about collecting these data and interpreting these data, the more we see, areas where we are not yet perfect. And I think it's a continuous process that we have to actually go through to actually make our data collection and interpretation better. The other point is one challenge I see. If I take the example of the work that Claude is doing with the batteries product environmental footprint, this is what we appreciate, an open dialogue with the value chain actors where we can actually share our data, where we can discuss together rules. We see right now a trend that sector-specific guidance is developed, going beyond batteries. So there are initiatives from the automotive sector where all of a sudden others think that they should define the rules, how we in the metals industry, so not only cobalt and nickel, but in the broader metals industry, should collect and interpret those data. And that's clearly a challenge that we all have ahead of us. And I think, Tom, with your question, you already gave the answer. I think it is important that we as metals industry consolidate the work that we are doing, that we are clearer on the methods that we use, on the parameters that we apply to make it clear that we are the experts of our industry. We know how to collect these data. We know which are the best approaches to be taken, and that we can help different value chains in defining rules that have to be applied for their upstream industries.
Thanks. And Ketan, I noticed you raised a hand. So was there a point you wanted to bring up at this point with what Mark was saying?
Indeed. I think Mark was mentioning a really good point there. Just a reflection on that one, where when we're talking about different suppliers and different suppliers using different impact assessment methods, a consistency between them is really the key. And this is a humongous effort driven by you, and we thank you for that as a downstream user, whereas industry association partners, if they have consistent databases, it makes our lives much more easier and allows or enables this decision making, which is more data driven and which is more fair.
Absolutely. And I'm thinking of several initiatives at the moment that are ongoing just in the automotive sector, Katina X, Battery Pact, obviously GBA and PEF, the latter two I think are very well aligned, but there's a need for that consistency. Claude, did you want to raise a point there?
Yeah, maybe I would like to continue on this and elaborate on this topic about of new usages and expectations, because indeed what we are seeing at the moment, and we as a global industry association and for the batteries industry, we are really close, as I said, to the final usage by the end users of this product and the definition by the Commission of what the expectations are. And indeed, we are discovering, while moving to this ambitious target of communicating carbon footprint or communicating global environmental impact for batteries or other products, that there is indeed a need of better construction, better understanding of what are the technical requirements to succeed in such a communication, maintain this communication, have a fair comparison of products. And this is indeed based on, first of all, having access to this information. So thanks again for making this available. But then what we discover is that we need more than access. Then we need, for example, question on what are the uncertainty of the data, so they can be compared. Also, Mark mentioned about necessary dialogue and discussions with the industry on how to use this data, what they represent, and how they should be used to correctly inform the final consumer on what are the impacts, what that this means from the point of view of carbon footprint, but other impacts as well, and how they can be understood by the consumer in a way that's correctly related to the origin of the data, where they come from, what they mean, and what they represent. And that's not so straightforward that it looks. That's really need a clarification. This is a lot of work we are doing in this PEF exercise, which hopefully will be used and, as Mark mentioned, I think reproduced or let's say duplicated for other topics, because well, not all products have same sources of impacts. Not all products have same type of usage. And so all of these rules which define what the consumer will read when he will have some kind of simplified label saying, well, that's my carbon footprint, has to be carefully assessed and developed in a way that is meaningful and reliable for this information communication.
No, thank you, Claude. And nicely summarises the point. You know, at the start of the presentation, I talked about the harmonisation document that was created, and that was really a first step to making sure that there was consistency and potentially comparability with life cycle assessment. And it sounds like there's a lot of ongoing work that's needed to maintain that and develop on that. And I'm equally hoping that the PEF will be a good foundation going forward as well. Actually, I had some sort of wider questions around policy. I think you touched on secondary data and the use of secondary data around uncertainty and how we might better describe uncertainty of secondary data, which you might want to elaborate on. But also, I think, what sort of challenges do we face engaging policymakers? You know, this is not necessarily straightforward information to work with. You know, how do we best engage with policymakers so they can make best use of these data? Yeah,
thanks for the good question. Indeed, one of the points we are mentioning here is how to move from private, confidential, potentially confidential information, which are directly related to industry practices. And you mentioned clearly, of course, we have seen that the source of emissions when you're looking at the Cobalt data sets, there is a lot related to the energy usage, and we understand that this can be confidential industry information when it's come to unique and individual companies. This being said, of course, the objective is to make this as transparent as possible for the final user to understand when he's purchasing a product, where does the carbon footprint come from. And here we have indeed this question of how do we build a path, a transition from private data, confidential data, to publicly available data, still maintaining the confidence, maintaining the transparency, and maintaining the flexibility. So these are so-called these secondary data, which we believe play an essential use here. We understand that there are several ways to communicate information, and one of these major benefits of this Cobalt Institute information today is that we have now an accurate description of what is a so-called representative product, secondary information of data acquisition. This indeed is a major step in the PEF methodology in general, or LCE approaches, which is making sure that you can describe a representative product and make sure that all products comparison are based on a similar representative product. So there will be one more question which was not solved yet, which is who is owner of these data sets? And of course, you have been producing it. As you understand, the Commission, when making a public declaration of product environmental footprint and public calculation method, is aiming at a way to make this information at some point becoming publicly available. So there is still work to do here and clarify how we make this, organize this transition from these industry data sets to public information that anybody can use to calculate a carbon footprint. So these are one of the issues under discussions. We know that the European Commission is working on this topic. They are creating so-called, EF, environmental footprint official data sets, which indeed are supposed to take the best available data sets produced by the industry, but this has to be practically organized. And to conclude also this question of uncertainty of data. Having representative data is essential because it gives a good, accurate idea of what in average the material production can represent as an impact. But as well, we need to move to a more ambitious usage of PEF, which is not only on a voluntary basis. As you know, the carbon footprint declaration for battery will be a mandatory exercise, which means that every company will have to make a declaration. And to do that, it is essential that the numbers that will be declared can be, first of all, be assessed and demonstrated as reliable, but also can be compared. And to compare a number to another, you need to have some idea what the uncertainty is. Otherwise, it's really difficult to understand one number is higher than the other if you don't have any idea of what the uncertainty is. So this is still an exercise that probably, and maybe it could be a challenge for you as well, as
absolutely
further development in trying to assess when providing a number of typical representative product, what should be the attached uncertainty so that later further communication and usage of this uncertainty can be used in the, particularly in the public usage of these carbon footprint declarations.
Absolutely, and I think perhaps a challenge for us and a challenge for Mark as well, thinking about this on uncertainty in our data sets and how we manage that as well. Which I think leads just on this section. I want to close off with Ketan, and so we looked at sort of limitations of industry averages and on uncertainty, and so for end users of LCA data like yourself, what limitations do you see around, say, uncertainty, or perhaps the frequency of the updates for these data and so on? What sort of challenges are you experiencing as a data user?
Thank you for the question. It is really important to figure out how to deal with the uncertainty, and is it even possible to quantify the uncertainty, and if yes, then how to integrate that with the actual result. There are some developments currently in progress, so to say. But then coming back to the limitations of this is that we have a representative picture to work with, which allows us to figure out general decarbonization measures and work with them. But that does not fit for each and every stakeholder. It might vary depending on which field it is, or depending on which conditions is it produced in, and if there is a possibility of renewable energy, maybe it's already being used, and that is perhaps not the hotspot. So when we're working with more specific data and an industry average data, then we lose the granularity, and that is important to drive very specific decisions.
No, thank you. I think that raises a good point, which is, of course, this is industry average, global average aggregated data sets, and you have different ore routes. You have a nickel cobalt, copper cobalt, and so on. And yes, you will have potentially different hotspots in different routes. So yeah, I think a key point there as well. Thank you. Well, I think we've talked a lot about challenges, and perhaps nice to be optimistic and look at opportunities. So, Mark, I think we've touched on this already, but perhaps you could explore it a little bit more. Opportunities around consistency of approach and communication seem to be key. I think the communication piece as well. And I guess any opportunities you see to improve harmonization and perhaps even also coordination of industry efforts as well. Any thoughts on that?
Absolutely. I think that is going to be key from different perspectives. I think first of all, the cobalt industry as well as the nickel industry and many other metals are committing since many years to collect these data. And you mentioned this harmonization document that was published in a peer-reviewed journal back in 2014-15, which was a very good starting point where we agreed on some generic rules. And the discussion in the meantime has evolved. And Claude is following the discussions around batteries, where a lot is actually concluded from which we can learn and that we should actually take into account in our work to actually harmonize the way that we are collecting life cycle data within the metals industry. And a very critical point is, of course, that, for example, between cobalt and nickel, we have many overlaps, that many of our producers are also producers of cobalt and vice versa. So harmonizing the way how we are collecting these data is going to be of critical importance. And I think that on the other side, we can also create a lot of synergies for our member companies. If you think about, synchronizing the activities, that would also mean that the companies only have to do this effort in collecting the data once to satisfy the data requirements that, for example, we come up with to Robin on the nickel side. You're doing the same on the cobalt side, and other metals might also be there. So clearly, that is an opportunity that we have to take and that we are working on. So there's a lot of work ongoing under the umbrella of the International Council on Mining and Metals, ICMM, and we hope to have such a harmonization document ready by 2024, 2025.
Yeah, thank you, Mark. I think absolutely there's perhaps some duplication of work that we can attempt to address and work more closely as industry associations, really helping our members and supporting our members, especially that data collection challenge, and I think it can be a challenge at times. And I think also thanks for highlighting the ICMM work as well. Again, another industry approach to try and get this harmonisation going forward. Back to you, Claude, and I think there's obviously a lot of areas that need to be introduced into PEF, and there's technical data that needs to be understood. Do you see any sort of capacity building opportunities with policymakers? How we communicate these results. Do you see there being an opportunity for industry to support policymakers more in their work and their decision-making processes?
Yes, that's a very good question. Certainly here we have opportunities. As an industry association, of course, for the full value chain, we have this view as well, that, of course, industry can be more proactive, and as long as we are capable of defining our own road, and here we are talking about gathering information, having a harmonized approach, mentioning about this question about making progress on let's say, timely updates and information about, for example, uncertainties and other aspects. All of these are of high importance indeed to clarify how can the industry support the policy expectations. Of course, as you know, on one side, the policy expectation can be huge. I mean, some of our politicians live in the future. They imagine, this so-called sustainable product. I would go even, with some lack of knowledge, maybe from some of them, in the zero carbon production of metals, which I believe is just a dream. We know that our industry is energy intensive and so on. But what I'm referring to here is about, the method for offset of carbon footprint. You mentioned also the direct reduction of emissions by using more sustainable energy during the manufacturing process and so on. And clearly here, I think we have as an industry this opportunity to demonstrate, first of all, that progress can be made, significant progress and decarbonization of the full value chain, and as well demonstrating or showing how this can be measured, integrated, communicated, because that's really what we wish to do as an industry, demonstrate that we can contribute in a practical way to this ambitious vision of a decarbonized future and so on. what we can then practically do is indeed do what you have done right now, indeed, providing these advanced LCA transparency information on what that the industry identified their own hotspot, that we are capable of improving them and making roadmap there. And these indeed should result in better understanding by the policymakers that the industry contribution is indeed a voluntary driven, very efficient tool to move to these decarbonization targets that we have, and not only wait, in let's say, old-fashioned type of policy making that political decisions are made, and then industry is just, pushed forward to the right direction that they didn't anticipate. So that's I think, it's something that from the past, the future we see is indeed in a better communication. I would even say go to partnership between industry and authorities to really prepare the right way to move toward this green transition that everybody is looking at, including in the industry.
Absolutely, and I think that's a great point, because we talk about these our metals as being critical to the green transition, but we need to earn our place there, and that's demonstrating through decarbonisation. I'm mindful of time, so I'm going to start to sort of wrap up our questions, but over to Ketan, and I think will increasing in frequency of the LCA results and sort of consistency, will this support the work that you do going forward?
Indeed, and I think this is another important point where we need to make sure that we get the periodic updates regarding the work we are doing, so to say, as a whole industry players, that it allows us to track our progress and see that it is really towards being more sustainable. And the second point is being consistent with what was the system boundary defined before. Are we not just changing the system boundary as we wish, and we're making sure that it is consistent with the rest of the studies done to make sure that we are only comparing apples to apples and not changing the scenarios, so to say, and comparing with different set of results.
Excellent. No, thank you. And I think finally back to Robin. This is a mixed one. Do you see sort of increasing frequency of LCA as a challenge or an opportunity, really, going forwards as a company, and the potential additional burden?
Yeah, definitely an opportunity, Tom. I think organisations and operations are developing greater capacity and efficiency in maintaining the data needed for these processes. And if we had, say, for example, annual updates of the LCA, I think that would be extremely useful for analysis of the trends in industry and to avoid the issue of data lag, where technological improvements might not be discernible in the context of increased production. So, you're sort of looking to demonstrate the positive things that you've done, but also you're doing it in the context of, a very rapidly changing environment. So I think the frequency helps to, make that benchmark more useful over time. So, yeah. I am enthusiastic and probably a little bit of an overachiever, but yeah, that'd be great.
Wonderful. Well, I think that's a really positive, optimistic way to sort of close off sort of our panel questions there. Some real ambition going forward for LCA, so thanks for that. Our audience have been listening intently. We have a couple of brief questions which I'm just going to answer first. I think I'm probably best placed to answer some of these. So, while the data from China, broadly speaking, is less robust currently, are there any market participants that are included in the study? So just to be clear, from the refining side, there are no Chinese refiners included in the study, and I guess that's an ambition going forward to have that sort of to really increase the robustness of the tetroxide and the sulfate figures would be to include that where obviously there is a significant proportion of refining taking place in China. And then we have another question. Has the LCA examined, or are there plans to examine, how different end-of-life treatments affect or impact cobalt, like recycling or disposal. Well, just on that, our system boundary is cradle to gate, so we don't consider sort of end of life there. It is something we're looking at. Mark, I know we've had some conversations around end of life. If maybe briefly for a second you could touch on that.
Yeah, it's. I think when we look at the raw materials as such, then usually we collect these data from cradle to gate. But of course, looking here at clothes and the work which is done around an entire system like batteries, there we also include recycling. We also look at the recycling stage, and we actually ensure that the benefits from recycling are taken into account. But from our perspective, as our industry for the time being is predominantly basing its inputs on raw materials, primary raw materials. But of course, this batteries market is going to change the picture dramatically. So more nickel is going to come to the recycling, also to our installations.
Absolutely, and more cobalt as well, with the legislation now requiring minimum recycled content in years to come. Well, I think I'll want to close off the session now. I know we're slightly overrunning now, but just to summarise, I hope you've, as an audience, have found this session informative. It's helpful. I think some really insightful reflections from our panel today. First of all, if you would like more information on the Cobalt LCA, please go to the Cobalt Institute website. You can request a copy of the full report, and there's information there. And any sort of wider questions about Cobalt, please do come to the Cobalt Institute as your first port of call. And the LCA data, as I said, will be also available on databases shortly. So I guess that leaves me just firstly to thank our panelists today. Thank you very much for your contributions. I think really interesting, and appreciate your time today. Thanks to the technical team here as well for your support. And of course, thanks to you, our audience, for joining us today for this session. Have a great day. Thank you.